Okay, good afternoon, everybody, and happy Friday. We're going to go ahead and talk about graphing lines, linear equalities, and systems of inequalities. So just a few reminders on how to graph lines. So most of our lines are going to be in slope-intercept form, and if they're not, we can go ahead and put them in slope-intercept form. So if we recall that y equals mx plus b, where m is the slope and b is the y-intercept. Okay, remember that the y-intercept is on the y-axis, hence the name y-intercept. Okay, and if any of the problems are not in that form, we can always solve for y. We do have our special lines, which we'll get to in number 3. But if we take a look at number 1, it's y equals, so we can go ahead and say that this is the slope and this is the y-intercept, and we always write the y-intercept as a point, so this is 0, 1. Okay, and the y-intercept is always the starting point of your graph. So you're going to go to 0, 1 on the y-axis and plot a point. Okay, and then when we graph this, remember that slope is the change in y over the change in x. So remember that we always go up or down first and then left or right. If our slope is positive, we rise to the right. If our slope is negative, we fall to the right. So in this example, our slope is negative, so we need to make sure that we are falling to the right. Okay. So I'm going to go down 3 into the right 2, down 3 into the right 2. I could also go up 3 into the left 2 as long as 1, 2, 3, 1, 2. As long as my slope is falling to the right. Okay? And then on a quiz or test, you would make sure that you use a straight edge for this to make sure that your lines are nice and neat. Okay? All right, so there's example 1. Let's go ahead and take a look at example 2. So notice in this one, y is not by itself, so the first thing I want to do is solve for y. And in order to do that, I need to subtract 4x from both sides. So I get negative y to equal negative 4x plus 2. And then I divide everything by negative 1. Make sure that you divide all 3 parts by negative 1. So I get 4x minus 2. So here is my slope. And then my y-intercept is 0, negative 2. So I'm going to start at 0, negative 2, which is on the y-axis. And then my slope is a positive number, so I'm going to go up 4 this time and to the right 1. Okay. Or I can go down 4 and to the left 1. Okay. On these problems, you need to make sure that you graph at least 3 points. Okay. All right. In example 3, this is what we consider a special line. I don't know if you guys heard this when you were in previous math classes, but I always say hoi vux. Okay, so H stands for horizontal. The O stands for 0 slope. And then the Y stands for Y equals a number. And then Vux, V stands for vertical. U stands for undefined, that's the slope. And then X stands for X equals a number. So in these special types of equations, we look to see if it's just y equals a number, meaning that there's no x because it's 0 times x since the slope is 0. Or in this example that we have, x equals negative 5. So that's going to be the Vux part. X equals a number means it's a vertical line and the slope is undefined. So I go to where x equals -5, I make a point, and then I'm going to draw a vertical line. Okay. Once again, you would use a straight edge. Okay. Now, if you ever have a question which way you're supposed to draw these, so if I asked you what x is right here, you would tell me -5. If I asked what x was here, you would say -5. Here, -5. So no matter where you go on this line, x always equals -5. All right, so that concludes the little recap on how to just graph basic lines. Okay, if you're ever not sure, remember that you can always look things up on the internet on how to graph a line, slope-intercept form. There's plenty of information out there. So the next thing we're going to talk about is linear inequalities. Okay, so just a few reminders on linear inequalities. If you have a less than symbol or a greater than symbol, it's going to be a dashed line. And then if you have a less than or equal to or a greater than equal to symbol, it's going to be a solid line. So a dashed line means that any point on that line will not work in the inequality, but in a solid line, any point along that line does work in the inequality. Okay? So just as a reminder, when you have an equal sign, okay, you just graph the line and there's no shading. If you have an inequality, so inequality symbol, then you should be thinking to yourself, I need to shade. Okay. It's a very common mistake on these problems to forget to actually do the shading part, which is kind of the most important part. Okay. So for number 1, the first thing you want to do is make sure that y is by itself, which is this. And then the next thing I want to do is graph the line. So here's my slope, which is 2. And then my y-intercept is 0, -5. So there's 0, -5. My slope is a +2, so I'm going to rise to the right. So I'm going to go up 2 and to the right 1. And then down 2 and to the left 1. And when you're doing inequalities, you're going to want to take up the whole graph. So you're going to want to extend that line the entire length of the graph. Okay? And since this is a less than symbol, that's less than, I'm going to go ahead and use a dashed line to complete this. Okay. So once I complete the dashed line, then I need to figure out which way I need to shade. Remember that in inequality, several solutions will make the inequality true. So if I asked you, give me a number x is greater than 5, there's infinitely many numbers that are greater than 5. So I need to represent that on a graph with the shading. Okay. So what I always tell my students is to take a point and test it. I do understand that, some of you might have been taught if it's less than, shade below, if it's greater than, shade above. But I kind of think the safe way to do it is always to test a point. And the point that you always want to test is a point that's not on the line, okay? On the line won't help you decide on which direction you need to shade, okay? So if you can, the most simplest point is to test 0, 0. Okay, so I'm going to take 0, 0 and plug it into my inequality. So 0 is less than -5. Is that true or is that false? Hopefully you would say false. Okay? If it is false, then that means that that ordered pair cannot be in the shaded region. Okay, so I'll say that again. If it is false, this ordered pair that you just tested cannot be in the shaded region, because the shaded region means that any of those ordered pairs work for the inequality, and we just said this one doesn't, so it can't be in the shaded region. So that makes me conclude that I need to shade away from the point. I need to shade in the opposite direction of the point. And then that is going to be the area that I shade in. Okay, so once again, how did I know to shade on that side? Sorry for that last one that went over the line. Because when I tested 0, 0, it didn't work in the inequality. And if a point doesn't work in the inequality, then it can't be a solution, which means it can't be in the shaded region. Okay. All right, let's go ahead and take a look at number 2. Okay, so the first thing we need to do is solve for y. Hi, Wrigley. So let's add 4x to both sides. And we get negative 3y is less than or equal to 4x plus 6. And then I need to divide by negative 3. Okay. Hopefully this rings the bell right here that when you divide or multiply by a negative number, you need to switch the inequality symbol. So this is going to result in y is greater than or equal to negative 4/3 x minus 2. Okay, so that's a good active note to take, that when you multiply or divide by a negative number, so if you literally are saying to yourself, I need to divide by negative 3 or I need to multiply by negative 3, then you need to switch the inequality symbol. All right, so let's plot our point at 0, negative 2, and then my slope is negative 4/3, so I need to fall to the right. So I need to go down 4 and to the right 3. 3, 4. Okay, and then since this is greater than or equal to, I'm going to use a solid line. Okay, and then I need to figure out the shading. So 0, 0, remember we test a point that is not on the line. 0, 0 is not on the line, so it is okay to test. And then my suggestion to you is always go back to the original inequality, just in case you made a mistake about the whole flipping. I always go back to the original inequality to see which way you shaded. So if you made a mistake here and then didn't graph things correctly but based the shading off the correct original inequality, then they still give you points for the shading. All right, so let's plug in 0, 0 into the original. So I get 0 minus 0 is less than or equal to 6. So is that true or is that false? That is true. So if it's true, then that means your ordered pair that you just tested needs to be in the shaded region. So I'm going to shade to include the point. So if it's false, you shade to not include the point. If it's true, you shade to include the point. Okay. All right, let's go ahead and take a look at number 3. Okay, for number 3, this is a Hoy-Vux line, so y equals less than or equal to negative 7. So I can just go ahead and draw a horizontal line at y equals negative 7. It's going to be a solid line because it's less than or equal to. And then give me a number that's less than or equal to negative 7. So hopefully you would say like negative 8, negative 9, negative 10. And all those numbers are below this line. So then I want to shade below. Okay. You can test a point. You're still going to get the right answer. But for these, you can just ask yourself what's true and false and which way to shade. Okay. All right. So the next thing we're going to do is we're going to do 2 problems together on linear inequalities. And then you're going to do 2 problems with a partner and then get your answers checked off in the front. So let's go ahead and go to the next page. And as you can see, this is a system of linear inequalities, and a system just means 2 or more inequalities, okay? And what we're going to do is we're end up graphing where the shaded regions overlap. Okay? So for the first example, I'm going to do this first line in blue. So I'm going to start off at -1. And then I'm going to rise to the right 1/1. And